Hello everyone, and welcome to my talk on adapting your applications for Android 11 privacy changes. For the ones who don't know me, my name is Yacine Rezgui, and I'm a developer advocate at Google on the Android team. Smartphones are now such important devices for users holding their personal and private data. On Android, privacy is an area where we have been evolving over the last several releases, and we're continuing to do so on Android 11. Android 10 brought changes in that direction for us to evolve our platform to bring even more protection of users' data. So today, we will talk about new enhancement in Android 11, permission changes, scope storage, foreground service types, package visibility, and data access auditing. So first, let's talk about one-time permission. When they're given a choice, users always prefer to share less private data with their applications. We also saw that many applications request background location access with no need for it. Based on granular and developer feedback in Android 11, we're bringing users more granular control over device private sensors, location, but also camera and microphone, and significantly limiting access to the background location. Users will be able to grant temporary one-time permission for location permission request, which means whenever an application will ask for permission and the user only grant only this time, your application will have access to that permission while there is a foreground service type using using that permission, or if your application is in the foreground. But as soon as your application is being closed, or that foreground service is being closed, that permission will be removed automatically. And that goes for microphone access too. Imagine an application where the user can call the support. As a user, you don't use that feature that often, so giving access all the time is not something you're comfortable with. So in this case, the user can make a voice-only call, for example, and they can choose the option of granting access only this time, so allowing the application to have access to the microphone, but not all the time, while this application is running only specifically for this time. Same thing for camera access. So you may have this important question in mind. Do I need to change anything to work with one-time permission? Well, if you have been following our best practice regarding permissions, you don't have to change anything. If you're not aware of them, let me show you in code what it means. So first, in this use case, the user taps on the location button. So we check if that permission has been granted or not. And after that, we let the system decide if we need to show rationale or not, as an in-context UI explanation to give more context why we need to have access to that permission. If we don't need to show rationale, we'll request the location permission, which prompts a system dialog offering the user three options. Only this time, while using the app, and deny. And let's take the case where the user pressed deny. In such case, the onRequest permission result callback will be invoked. The permission was rejected, and we should make sure to explain which functionality won't work because of that decision to the user. We need to bring more clarity. They may not have been understanding the request before. We could show that in a snack bar, for example, like in this screenshot. To simplify the code to write to handle permissions, I invite you to check the newly introduced Activity Result API, which is part of the Jetpack activity and fragment libraries. To give users fine-grained control, in Android 10 we splitted the permissions between foreground and background location access. Applications are encouraged to incrementally request this permission to give users better control. First foreground, and after that, all the time location access. That was a recommendation in Android 10. In Android 11, this pattern has become a requirement. There is no change to foreground access request. This will be adequate for most use cases. Getting location to show the list of restaurants nearby, that works as before. And for background access, when you're targeting Android R, so Android 11 SDK, there are two changes. First, it's good practice to incrementally request permission to give user a chance to understand and decide based on context. So you should not ask straight away for background because first, it's a requirement now when you target Android R, and a lot of users weren't understanding why application were asking them from the beginning to have access to this permission. So first, ask for foreground, make the user aware and understand the value of it, and after that, upgrade to background location access. And when your app requests background location permission, the request permissions API will send the user directly to the settings instead of showing the regular permission request dialogues. So it's good practice to educate the user before requesting the extra permission with some sort of explanation UI, like that they understand why I'm being sent to the settings. And after that, you need to make sure to provide the option for the user to refuse before asking for that permission, because we have a rate limit. So to limit abuse rather than sending every single time the user to the settings, after 2 refusal, so after 2 times the user deny you that request, you won't be able to send them to the settings directly. So keep in mind, you need to ask them first, making sure they're aware of the permission request coming before showing it, because after 2 denial, you won't be able to send them to the settings directly. So afterwards, if they want to grant you access, they will have to do that manually, going by themselves to the settings of the application and grant you the permission. So we made it easy for developers, no new API, it's just there is a change in terms of user experience and you need to be aware of that. So to ensure compatibility for application targeting Android 10, so API level 29, it's still allowed to request both foreground and background location permissions at the same time. And we have this extended dialog shown instead, rather than sending to straight to the settings. You can have that permission coming up to the user. Keep in mind that's only if you're targeting Android 10, and we highly recommend you to upgrade your target SDK to Android 11 SDK, which is Android R. So this is just for you to give you more time for migration, but try to upgrade as soon as possible. It's good for you, it's good for your user, more transparency, more control. All right, now let's go to data access auditing. When we talk about transparency and data access, a lot of users want to be able to understand why an application have been accessing a certain private sensor. And as an application, it may be hard, especially if you have a lot of code in your app and it's kind of hard to figure out which part did it specifically. For large applications, you may have thousands of lines of code, maybe even millions of lines of code. You may have some orphan code. So some code that has been written by someone, that person left the team or no one is taking care of it anymore. So you may have accidental data access without knowing it. You may have dependencies, so using third-party SDK, closed source or not, that is accessing the location, maybe the camera, maybe the contacts, and maybe you're not even aware, open source or not, it may be hard for you to debug that. So in both cases, these access patterns may or may not be intended, and it's not always easy to identify as a developer. As the code base grow up, you may have a lot of connections with these private sensors, and it may be hard for you to figure out which one access the contact specifically, or the microphone, or anything related to the context API there. So with Android 11, we're bringing 2 new APIs to help you there. The basic feature is a callback when data is accessed. So we will call you whenever you're trying to access these private sensors. And on top of that, we allow the developer to attribute access to logical features within the application. Let me show you what it means. In this picture, each blue line represents a piece of code in the app, and the gray line symbolizes that this code accesses certain private data. Whenever an application calls an API that returns private data from these sensors, the system calls into a collection handler immediately before returning to the calling code. Hence, at this time, the collection handler can collect a stack trace to record which code performed the access. Let's look at the API to understand a bit more. This shows how to set up a callback for data access through the AppOps Manager class. So if you want to consistently track for the entire application this kind of access, you can set it up within application.onCreate, for example. Say you want to localize it to a particular part of your app. You could do it within activity.onCreate. Within the onAppNoted callback class, your application will be notified of data access in synchronous calls. When this happens, you may log the stack trace to help you identify the source of this access. And asynchronous access, for example, when your app registers a callback listener for geofencing, for example. For more complex applications, you may have a lot of distinct features. For example, a mapping app may have a navigation, explore nearby shopping, and find friends feature. In Android 11, we allow application to attribute a subset of the app as belonging to one feature when using the data auditing API. Each of the features use a subset of private data. So maybe find friends in this case is accessing the location and the contacts. Having features as a higher level concept compared to just an area of codes makes it easier to find what features have accidental data accesses if you are not aware of that. Further, this will make it easier to explain to the user what private data is used for. Data Auditing API allows you to attribute data access to features. Let's see how to do it in code. To attribute features in your code, create an attribution context and give it a meaningful name that corresponds to your feature. For example, find friends. Then you can pass this context to API calls. And within the auditing callback, you can recover the attribute through this variable attribution tag. Then you can, for example, track the attribute with your analytics solution and associate a particular feature with private data access. So rather than using in Kotlin, for example, context, which is a property given within your activity or fragment, you will use create attribution context, which is the same thing. You're going to get the same context, but labelized as the string given as a parameter. To provide better accountability for apps to access private data in the Foreground service, we've added now a couple of new Foreground service types values, microphone and camera. We introduced the concept of Foreground service types in Android 10, so application can declare their intention to access this information within its Foreground service. Only two types were enforced. It was media projection and location, but you could still use it for companion device, media player, sync, and phone call. There's a couple of new additional Foreground service types in Android 11. Camera is one of them. Since Android 9, application can no longer access camera in the background, so for quite some time this can only be done in the foreground. If your application targets Android 11, it additionally needs to declare the new types, else the Foreground service can't receive data. Here's the manifest entry for camera. If the Foreground service needs to access different data, you can declare them together. The idea here is to be able to make sure whenever one of your Foreground services is accessing these private sensors to declare precisely what's the use case for, to bring more transparency to the user again. So to recap, on Android 11, if you need to use a foreground service to access any of this data, you must declare the corresponding foreground service types in the manifest. And now to talk about package visibility. On Android 10 and older, this API and others allow applications to see which other applications are installed on the device. To provide better accountability for access to installed application on a device, Android 11 includes some changes to how application can query and interact with other applications. For several common scenarios, you don't need to make any changes, and let's have a look. If you target Android 11, this API will return the package info of your own app as expected. And it will return only the calling application, certain system packages such as the media provider that implement core Android functionality, but other applications won't be visible by default. If you send an implicit intent for another app to take action, for example, to use the image capture intent with the pre-installed camera app, that will work as expected. If there is more than one eligible application, the system will show a dialog box for the user to choose from, and that works. You don't have to make any change for that. For example, another call calls your application content provider and expect results. For that, you don't have to make any changes. That application will have to update its manifest, but you, as a content provider host, you don't have to change that. Besides the scenarios we just discussed, by default your app will return name not found exception regardless of whether com.another app in this example is installed or not. So by default, trying to access another package name that is not yours or the system packages as I mentioned, you just won't be able to find out if that application is installed or not. But you may have a use case where you need to make sure that this application is installed. For that, let's see how it goes in terms of code changes in your manifest. If you need to explicitly interact with another app, so in this case, an activity or bind to a service, com.example.store or com.example.service, you need to add this query property in your manifest and list the packages you want to directly interact with. And multiple packages entries are permitted. But if you want to handle all the applications that can send an image, and specifically a JPG, for example, it may be hard to list all of them. There may be hundreds of thousands of them in the Play Store. So instead, you can put this query intent filter where you just put the intent name as well as the filters accepted by that intent. So in this case, it may be my type, for others may be different. And by doing that, by adding them in your manifest, you can call get installed packages and see all the applications that can handle this specific type. In practice, we found that most applications can easily express necessary package interactions with intent and package declarations. But you may have a specific use case where you need to see all the packages. Keep in mind that using this new permission, query all packages, which allows you to see all the packages by having it enabled, it will trigger a review of your application within the Google Play Store. So it's not an automatic permission. You need to explain the reason why, maybe for example an antivirus, but you need to explain properly and your application will be reviewed for it. It's not an automatic permission. And sometimes if a social map, point of interest application fires a view intent with certain URL, as a developer you may don't want to send them to the browser. You want to handle that with the default native application. And by default, just launching the intent in this way wasn't possible. You will have, in this case, launching Google News, you will have both Google News, the default native application, as well as the browser. It may not be the experience that you want to give to the user. So with Android 11, we're bringing a new flag to help you doing that without having to declare anything else in your manifest. flag activity require non-browser allows you to be able to get only the native application that can handle that. So applications that are not considered as browser, and to launch within them without having to see the browser in the launch dialog that I just showed. And in case we cannot find that application, any default native application, you will have the activity not found exceptions being raised, and you can catch it and instead open the URL, so here Google News, in a Chrome tab, so a custom Chrome tab directly in your app rather than opening a browser, which may not be the experience you want to give to your users. And doing that doesn't require any change to your permissions nor your manifest. So I highly recommend you to use this new flag to help you having the best user experience for your users. If you need to test package visibility, which has big impact on Android 11, you can use this ADB tool, which allows you to enable or disable package visibility. And if any of your requests to the package lists is denied or blocked, you will be able to see it directly in Logcat and help you debug that. And now let's talk about scope storage. So before the introduction of scope storage in Android 10, there were two classifications of external storage: app storage and shared storage. The app storage is the external storage folder of your application, which is directly tied to your application. It's deleted when your application is deleted. And previously it has been a bit abused by developers, and that's not something developers in general are comfortable with. So with Android 10, we bring this distinction where app storage should be specific to yours, and shared storage is the open storage where every application can contribute and add files there. With Android 10 scope storage changes regarding this distinction, we also brought the media files and other documents. So something we've seen with users is most of the time application needs to access media files, so to share a video, a photo, or even an audio file, but the other documents, which may include a bill, a bank statement, that's something that users may not be comfortable to give access by default to all of them. So rather than application gaining access to all the files in shared storage, they only now have access to media files. And in order to gain access to documents, which could potentially contain more sensitive data, the application needs to ask the user to grant access specifically to those documents. We will see how can we do that. So with Android 10, we brought unrestricted media and downloads contribution. So you can add any media file or a document file to the downloads folder without even having to ask permission, because those files are created by you. It's easier and better than asking directly to have access to all the storage and having less denial by users, because you can just do that automatically. And only media collection can be read with the storage permission. The location metadata requires permission. So for every media file that have location, so the coordinates where that photo or video has been taken, by default, application won't be able to see them if they don't request the location permission. Again, it's to bring more transparency and more granularity access to the users. And the system picker is the default way to access all the other non-media files. So the document can be a CSV, PDF, or more. And finally, to read or write outside of your collection requires the system picker. So again here, if you want to add a file that is not a media file or not within the download folder, if it's a specific folder you want to create, or files like a zip file you want to add it somewhere else in the Android storage, you have to use the storage access framework and ask the user to put it where they want them to put. Android 11 improves upon scope storage in a number of ways. So let's have a look. First, we've made further adjustment to storage permissions. So instead of seeing storage, which is kind of generic, it doesn't mean a lot to users, we have now files and media. It's more clear to them what kind of permission they're granting to applications. And with Target SDK version R, write external storage and write media storage does not grant any additional write access. So here the goal is for you, rather than having to ask more permission that may be too invasive, you can just stick to read external storage and with that be able to do all the modifications you need. In Android 10, we are required user consent to edit or delete media not contributed by your app. So with read external storage, you can access all the other media files, but if you want to delete or edit them, you needed to ask the user consent. And to do this, you must use the Media Store APIs to trigger a dialog to request user consent. If the user accepts, you will get a call back into your application and you can proceed to access the file either with the Media Store APIs or with the file path. In Android 11, we're improving the user consent flow for editing and deleting media files. So you can now batch multiple edit or delete requests in one dialog rather than pop one dialog per request, which is kind of cumbersome. And this should significantly improve the UX in your application, and it was a popular request from you in Android 10. So we are thrilled to deliver this for developers. And you can always have the option to copy the file to your application directory on external storage and edit the copy, but we would only recommend this for one-off edit or small-sized files, since we don't want to clutter our user disk and the copied file will be counted against your app's disk usage. So if it's a really big video, think twice before trying to bring it directly to your app directory. So with the Media Store API and bulk edit access, the way to use it on Android 11 is to call mediastore.createWriteRequest, and we have the other types of requests there, with a list of the content URIs you want to modify or delete. You'll send that as an intent, and once you get a result, you will be able to access them, delete them, or remove them. We also brought some file access restrictions, specifically to app action open document tree. With Android 11, you can no longer access the following folders and files from the documents UI, so storage access framework: the root of the internal storage volume, our SD card volume, the downloads folder, and the Android data and Android OBB directory and subdirectories. So for the root and the download folder, you can still access one specific file or one specific subfolder, but you cannot have the root of the whole storage volume or the whole root of the download folder. And for action open document, you can no longer access directories, subdirectories within data and OBB of the Android folder, because those are specific to applications and we don't consider them being visible or accessible by others an option. So our general guidance for the ones who want to use the direct file path access, which has been a really expected feature for native developers who use FFmpeg, for example, that need to have access directly to the file API, the one you have been used before, we introduced a proxy now that you can use the same API as previously, but underneath use Media Store. So it helps you to still deal with file API if you prefer to use it for retrocompatibility, for example. But keep in mind that if you need to have the best performances, we highly recommend you to use the Media Store APIs, because again, this new direct path access is just a proxy on top of Media Store APIs. And based on our tests, it may be expensive for opens and first reads. After that, the performance are really similar. So have a look, benchmark your application with these new changes and make sure to choose the best solution based on your needs. And keep in mind, performance can be an impact, specifically for application opening a lot of files. And we also brought a special app access, so a new permission that application can declare, which is manage external storage. and it allows you to have access to the whole external storage, except, as I mentioned before, the application external folders. And with this permission, rather than having a dialog coming up to the user, you will have to go to the settings, so you can trigger an intent for that, to be able to grant that access or not. And here, similar to the background location access, after denial, you won't be able to send the users directly there, and they will have to do that manually. Second thing is this special app access is being verified by the Google Play team. So when you use it for specific use cases like file manager, backup and restore, maybe productivity application that require bulk access to files, we put a Google Play policy online to help you figure out if your use case can be considered as accepted or not. And that will trigger a review when you're submitting your application. So here we've seen most of the changes on Android 11 regarding privacy, but there are still some small changes but still important. So let's go over them quickly, and after that, don't worry, I will be done. So before Android 11, the read phone state permission covers a broad set of information. It includes general states of the phone, such as is it ringing or idle, and more private information such as phone numbers, and it's not something that users may have been comfortable to share. So if you target now Android R, we've added a new permission. So read phone state, as it does, you can still access the state of the phone to provide a better user experience when the user gets a phone call or it's idle. And if you really want the read phone numbers and only them, you can use the read phone numbers permission. If your app only needs phone numbers, you may want to declare your permissions like this to make sure you still have a retrocompatibility with a max SDK version on 29 with read phone state and read phone numbers onwards if you're only looking for the read phone numbers. We're bringing also some MAC address access restrictions. MAC addresses are unique. On Android 10, we introduced a randomized MAC address whenever you connect to a different Wi-Fi endpoint, but it's still, as a hardware value, unique. So we consider that accessing it directly may not be suitable for users. So we've restricted this access, and you can see other changes that reflect that privacy commitment, and you can have a look online at our documentation to figure out how to migrate from that. Last one is restriction to the system alert window. So action manage overlay permissions intent no longer supports package name being supplied in the data URI. You can still draw or display on top of other apps, but only by asking the user to grant you that access through the settings rather than sending an intent directly to do so. Preloaded applications are still granted the permission by default, but installed application through Play Store or somewhere else needs to go through the settings and ask the user to enable it manually. So that's for me on privacy changes on Android 11. I hope you really enjoyed this presentation. Feel free to ping me on Twitter at my Twitter handle there, Rezgui on Twitter, and I would be happy to answer your questions, and happy Android 11 release. Thank you.